Hello guys, before starting this video let me tell you, please go and watch my previous video related to geometry and shape. So if you don't watch it, then you will not understand it. So let's start. So when the electron pair are 5 or the hybridization is 5, that is sp3d, s1p3 and d1, all we get 5. So we'll come towards this afterwards. There are 2 to 3 possibilities. That is, first is the 5 bond pair. These are the 5 bond pairs. Here we see this section. We have divided this 5 into this 3 section and the 2. This, for this axis, this bond angle is 90 degree, and for the angle between BAB for this axis, it comes 120 degree. So we should not divide 360 divided by 5, rather we have to divide by dividing it by ratio 3 and 2. 3 for trigonal, as in previous trigonal type of molecule, and 2 for linear kind of molecule. Not 2, 90 comes for 4. 3 we have to take here for the axis. For this it comes 90 for this axis, and for this it comes divided, we have to take divided by 3, it comes 120 degree. So next, the geometry and shape of this molecule comes trigonal bipyramidal, and shape is also the same trigonal, because all these molecules, this 3b and 1a central atom are in a triangle, a trigonal planar. And when we join this two b atoms to all these atoms present here like this, then we get a pyramid, and upper pyramid and the low downside pyramid. So it is two, therefore bipyramidal. Trigonal is the base or the planar shape here, and upper one pyramid and down one pyramid, so bipyramid. These are the examples, AB5 type molecule. Next possibility is 4 bond pair and 1 lone pair. 4 bond pairs, 1 lone pair. Same, the base is the trigonal, only there will be a distortion, or distortion means nothing. Distortion means simply there is a slight change in the bond distance or bond angles in the space due to repulsion in electrons. This is a trigonal bipyramidal shape molecule. Shape is same, but in geometry we don't consider this lone pair, so only we consider this 4 bond pairs. So it comes a seesaw geometry. uh, Seesaw geometry is like, if we consider this as a stand like structure, so this two will become like a seesaw kind of shape or geometry. We'll see it in the next we'll see in the next, we'll see after the all kinds of hybridization. I'll be showing it to you. Next is 3 bond pair and 2 lone pairs. Type is the same. Trigonal is the base. These three are the this will form a we have to do not consider this in geometry, so it will come T shaped geometry, and trigonal bipyramidal is the same shape as before. Next is 2 bond pairs and 3 lone pairs. This is the last kind of um, possibility of 5 hybridized orbital molecule. 3 lone pairs and 2 bond pairs. Trigonal bipyramidal is the shape. Linear is the geometry, because we have to consider only bond pairs. So it is a one line, or in a single line it comes a linear shape. So with this we have seen the angle. here everything is been sorted. Next we'll go for the 6 hybridized orbital, that is 6 electron pairs or 6 bonds we can say. sp3 s1 p3 d2, 3 plus 2 5 plus 1 6 hybridized orbital and 6 bond pairs. So in this case the spatial arrangement is like four atoms are placed in a square shape, square planar format, and two atoms are placed one above and one below. So the angle between this BAB or this bond angle, standard bond angle is 90 degree. So it has an octahedral shape and geometry. Octahedral because it has 8 shapes. When we join all these atoms which are outer to this A, that is central atom, except this central atom, if we join all the this B kinds of B atoms, this is not okay. So I'll show in my afterwards, after some time I'll show it to you how it has been seen. So next is, these are the examples. Octahedral means 8 faces, so it's octahedral. Next option, next figure is 5 BP and 1 lone pair. These are 1 2 3 4 5 bond pairs and 1 lone pair. It has octahedral shape, it has square pyramidal geometry because it these 1 2 3 4 it gives a square base, and this is a, if we join all these atoms which are present next to the central atom, then we get a pyramid structure, square pyramid geometry. Examples. Next, similar for 4 bond pair and 1 2 lone pairs. This is 2 lone pairs and 4 bond pairs, octahedral shape and square planar geometry because we have to consider all the bond pairs only. Example is this. Next, last one is the 7 hybridized orbitals sp3d3. There are angles 72 and 90 degree. It has 7 bond pairs. The only case which has 7 bond pairs, no other cases of lone pairs seen or found till now. IF7 is the only molecule seen of this geometry. So this is the pentagonal base, or pentagonal base is here, and if we join all these atoms except the central atom, we get a pi pyramid. Here we get one pyramid upper side, and downside we get another pyramid. So it is bipyramidal. Geometry and shape are the same. Next we are going to see the main, and now the angle is 72 and 90 degree. It comes with a though it has no distortion kind of thing because lone pairs are not present here, but the bond angle is here standard 72 and 90 degree, which we don't calculate from this 360 divided by this 7. So next, these are the standard ones observed. Next we are going to see the shape and geometry in a 3D way. So I have first taken the tetrahedral geometry. That means I have taken on here we have to join only the atoms which are away from the central atom. Here central atom is present, so we are only joining all the atoms around the central atom. So we get a tetrahedral because 4 phase. This is one phase, second, this is third, and the down one is fourth. This is the tetrahedral. Here we see the central atom. Tetrahedral shape and geometry, due to some distortion we get here geometry, because geometry here we don't consider the lone pairs. So here this is a diagonal pyramid. This is a trigonal base, and this is a pyramid like structure. So it is a trigonal pyramid. Next is trigonal bipyramidal. This is a trigonal base, and we get here upper pyramid and downward pyramid. We get here two pyramids after joining the only the atoms except the central atom. Next, the seesaw, the geometry we have seen in the previous case, that is, these is central atom and these are the which these are the B ones, B atoms. All these are B atoms. If we see here, this is like a stand, and these two atoms behave like a seesaw, like this seesaw. So this comes seesaw like geometry. Now this is an octahedron. Octahedral. Here we base is the like a square shape. It has a base. Here upper side one pyramid, down side one pyramid. Therefore this, and it has 8 faces, 4 of one pyramid, 4 of this second pyramid. 1, 2, this 3, 4 face, and here plus 4 face. This is 8 faces. This is simply a square base and pyramid type structure. Square pyramid structure. Last is the pentagonal bipyramidal shape or geometry. The same base is a pentagon type, and this is upper pyramid, this is lower pyramid, therefore bipyramidal. Thank you for watching my video.